Model 19, building a small Cisco network. So look at basic switch configuration, configure initial router settings, secure the devices, connect the switch to the router. So basic switch configuration. So a Cisco switch comes pre-configured and needs to what be assigned basic security information before being connected to the network. So elements that are usually configured on a LAN switch include what the host name, management IP address information, password, descriptive information. All right. So the switch host name is the configured name of the device. So for example, now it could be by default SWBLDGR room what 216. So the management IP address is only necessary if you plan to configure and manage the switch through an inbound connection on the network. So IP address permission that could be configured on a switch, it could be the IP address, subnet mask, and what the default gateway. So you can set all those up if you want to. Remember we're dealing with switches here, right? So in order to secure a Cisco LAN switch, all right, it is necessary to configure passwords on each of the various methods of access to the what command line. So minimum requirements include assigning passwords to remote access, all right, methods, for example the telnet or SSH. Then also you should assign a password to what privilege exec mode, so that somebody does not just connect to your switch and just enter into the privilege exec mode like that and start configuring things on your switches, configuring different ports for you without your knowledge. So remember that telnet sends what username and password in plain text, and it's not considered what secure. So SSH encrypts what the username and password and is therefore a more secure method. So this is a simple switch configuration. For example, now when you enter enable, so switch comes on, right? Configure terminal, right? You put host name. So host name now that's the name of the switch. So enable what secret class line console 0. So both password Cisco login, right? Line VTY015. Then you put the password again. So it as a service password encryption, blah blah blah. So these are just different switch configurations. Okay, on the Cisco packet tracer you see different examples of how you can configure different ports on the switch. So you can assign IP addresses to different ports on a switch via the command line interface. So to access the switch remotely, an IP address and a subnet mask must be configured on the switch virtual interface. All right, so to configure an switch virtual interface on a switch or an SVI, right? Use the what interface VLAN 1 global configuration what command. All right. So once you type interface VLAN 1, all right, it automatically takes you to where you configure what the virtual interface of the what switch. So next thing you do is what assign an IP4 address using the what IP address. All right, the IP address command. So when you put the IP address command, the next thing you now do what you enter what the IP address. Let me use my pen. So when you type the IP address command, all right, the next thing that follows what the IP address you want, then also the subnet mask. All right. So the last thing you would now do is what enable the virtual interface using what the no shutdown interface configuration command. So after the switch is configured with these commands, the switch has all the IPv4 elements ready for communication over a local network. So remember that switch configured with IPv4 address should also have a default gateway assigned. So this is done using the word IP default gateway. So when you put the IP default gateway, all right, once you put IP default gateway, you will now type the word IP address you want to use as what the default what gateway. So there's packet tracer activity here for you to learn and practice how to what configure switches. Let's look at configuring initial router settings. So when you want to configure a router, once the router is boot, right, you use the host name. Remember we did something like this, right? Put the host name after typing um the host name, right? You put whatever name you want to be the host name. Then you enter what secure privilege exec mode. All right. So from here you enable what secret password. You put password. All right. Secure user exec mode. This will now give the name of the console. So depending on the port you're using, console port you're using, all right, then you put what the password. So the next one is what secure remote telnet or SSH access. So this one now, all right, asks you what to what give that particular telnet or SSH what a password. So the next thing you're going to secure all password in the configuration file. So you do that by using what the service password encryption um, file command, and you would provide the legal notification. Then the next thing you now put the banner method, the meter message meter. Then you save the configuration. Then you just use copy running configuration, startup configuration, and that would be it. So this is just what's my mouse? Okay, that's just an example of how a router is being configured. All right, so now it said the following command secure privilege exec mode and user exec mode enable telnet and SSH remote access and encrypt all plain text. All right, so for example, enable secret class, blah blah blah, inline console zero. So when using the console port zero, you put password, login, exit, then configuring SSH. Just exactly this is just exactly what we saw in the previous slide. This is exactly how it is being implemented. All right. So the legal information warns users that the device should only be accessed by what permitted users. So now to protect network devices, it's important to use strong passwords, which we have already dealt with from the beginning of this training. How strong passwords are set up. So you use at least 8 characters. You make your password complex. You mix with uppercase and lowercase. Avoid passwords that are based on repetition, dictionary word, letter. Okay, deliberately misspell a password. All right. So change passwords often and do not write passwords down and leave them in obvious places. So for example now, these are uh, weak passwords. Okay, these are examples of weak passwords. Now look at this. How can you put a password and call it was secret? Your password is secret. Why is it a weak password? Because it's just a simple dictionary password. All right. Smith, how can you use a name as a password? Toyota, use the name of your car as a password. Bob 1967 looks like the name and the birth year of what the user. Blue Leaf 23, simple words and numbers. So, but when you want to use a strong password now, you can see this one B67N42D39C. So you can't even before anybody can guess this password, it's going to be crazy. Then look at this one now, it's even much more complex. You put 12 carat HU space, there's even a space here. So this one is super strong, right? Then also secure remote access. So when the device is connected to the network, it can be accessed over the network connection using what? SSH or what? Telnet. So SSH is the preferred method used because it is what more secure. So when the device is accessed through the network, it is considered a VTY connection. All right. So the password must be assigned to the word VTY port. So for example here now, when you just put this, all right, when you open the VTY port, right, for example, with this command, it asks for what password and you will set up what password. So transport input SSH. Remember they said do not use what telnet. Telnet is exposed. Telnet, every of your password will be written as plain text over the network. So let's look at before configuring SSH. The switch must be what minimally configured with a unique host name and the correct network connectivity settings. So verify that the switch first of all supports what SSH. So if, for example, you use the show IP SSH command to verify that your switch supports SSH, then the next thing you configure the what IP domain using what IP domain name. Then you put what the domain name that you want. All right. Next, to generate the RSA key pairs. So use the crypto key generate RSA um, command to enable the SSH server on the switch and generate what an RSA key pair. All right. So when generating RSA keys, the administrator is prompted to enter the module's length. A longer module length is more secure, but it takes more time to generate and to use. So remember I said it ranges from 64 bits, 128 bits, and even 500 bits. All right. So to delete the RSA key pair, use the crypto key zeroize RSA command. All right. So after the RSA key pair is deleted, the SSH server is automatically what disabled. So this means that that switch will no longer be able to be accessed over the what network virtually, wirelessly rather. So the next thing you configure what user authentication, which is what password. Okay, so to use local authentication method, so create a username. For example, you put username and you type the username secret, you type what the password. Then configure the VTY lines. All right, so enable the SSH protocol on the VTY line using what the transport input SSH. All right, so that configuration command what helps you to what start to configure what the SSH. So use the line VTY global configuration command and then log in local line configuration. So using the login enables you to what log into the what SSH. Then the next step is what to enable SSH version 2. So by default, SSH supports what both version 1 and version 2. So version 1 has some vulnerabilities. So use the show IP SSH command to see the version. So enable the version 2 by using what IPSSH version 2. Right. So on a PC, an SSH client such as what PuTTY is used to connect to an SSH server. So for the graphics now, the following has been configured. You can see SSH enabled on the switch 1 interface VLAN 99, all right, with IP address 172.17.99.11, all right, and oops, PC1 with what IP address 172.99.21. So use the show IP SSH command to display the version and configuration data of the SSH on the SSH server. So to check the SSH connection on the device to the device, use what show SSH what command. So you can see on the ISO here what this shows what the configuration, the version, the configuration data. So you can see the version 2.0, right? And you can see the key, right? See how long it is. So once you click on um the SSH, show SSH, it shows you what devices what that are connected or the different SSH connection. So you can see who started a session, right? The user is what admin. That's the username that the person used to start the SSH session. All right. There's a packet tracer um, lab attached to this. So now connecting the switch to the router, you need to, yeah, by then you should have set up the default gateway for the host. So if your local network has only one router, okay, it will be the gateway router, and all hosts and switches on your network must be configured with this information. So the default gateway is only used when the host wants to send a packet to a device on another network. So the default gateway address is generally the router interface address attached to the local network of the host. So the IP address of the host device and the router interface address must be the same network. So remember when you say the same network, this is, you can see this, they are the same. Are you seeing 192.168? So now let's look at the default gateway on the switch. So a switch that interconnects client computers is typically a layer 2 switch, a layer 2 device, and does not what require an IP address to function. So however, an IP configuration can be configured on a switch to provide remote access to the switch, right? Just like we talked about previously. So to connect to and manage a switch over a local IP network, it must have a switch virtual interface, which is the SVI configured. So the SVI is configured with an IPv4 address and a subnet mask and local LAN. So the switch must have a default gateway address configured to remotely manage the switch. Use the IP. So use the IP default gateway or a command, right, to set up what the default gateway of the switch. When you put IP default gateway, you put what the default gateway here. So this is an example of how it can be set up. There's also a packet tracer here. So we've looked at some things here, how to connect or configure the switch virtual interface for the switches, then also that's how to configure the default gateway of the router, set up, configure SSH, all right, or telnet, set up telnet or SSH. And I mentioned that telnet is not secure, so SSH is best, right? And there's also SSH version 1 and what version 2. So first of all, you have to check if your router supports what SSH what version 1 or version 2 rather, and if that supports, you just use the enable SSH version 2 command to enable SSH version 2, because SSH version 1 have some vulnerabilities that were worked on in what SSH version 2. So also the default gateway is only used when the host wants to send a packet to a device on another network. So the default gateway address is generally the router interface address attached to a local network. So the IP address of the host device and the router interface address must be on the same host network. So, and also a layer 2 switch does not require an IP address to function properly. But if you want to access that switch um, virtually or over the network wirelessly, you have to set up what the switch virtual interface, use the SVI. So the SVI is configured with an IP address and a subnet mask on that particular local area network. So the switch must also have the default gateway address configured so you can remotely what manage the switch from another network. So these are some keywords and some commands that you should have in mind. So lastly, we'll be looking at the module 20. All right, module 20 says troubleshoot common network problems. So we'll look at the troubleshooting process. All right, physical layer problems, troubleshooting commands, troubleshooting wireless issue, common internet connectivity issues, customer support. Now let's look at the troubleshooting process. So troubleshooting is the process of identifying, locating, and correcting problems on devices. So you can troubleshoot your system, troubleshoot devices. Anytime you're troubleshooting, it just means that you're actually trying to um, discover a problem, solve the problem. And another thing you need to know is that documentation is part of troubleshooting. So in cybersecurity now, for example, there's something called a cybersecurity playbook. All right. So a playbook consists of several threats that you have probably solved or mitigated over your experience. All right. So different organizations have their different cybersecurity playbook that they have come up with. So those documentations of how you solve the problem are what are located or um, added to the cybersecurity playbook. So documentation is part of the troubleshooting process and should include the following: a detailed description of the problem, right? The steps taken to determine the cause of the problem and steps used to correct the problem. So when gathering information, talk to the user and try to determine how much of the network is affected by the issue. Some things you might check for include the following: nature of the problem, that's end user report, problem verification report, check the equipment, alright, manufacturer, make or model, the firmware version, operating system version, ownership or warranty information, configuration and topology, whether it's a physical and or logical topology, configuration files, look at the log files also, and also the previous troubleshooting, whether any previous troubleshooting have been occurred on the system or have been taken in the system. All right, so that you can be able to track where the problem came from. Probably it's from a vulnerability that was left in the previous troubleshooting. Okay, so you look at out for all those information. So this is actually a structured way of us troubleshooting network problems. All right, so you start from the physical. So you start from the physical layer. Okay, so you go and access the physical components of the network. All right, this is now for moving through what the OSI model. Okay, so a good approach to use when the problem is suspected to be a physical one, all right, is by starting from the physical. All right, check the cables, check the ports, check if they are connected properly, check the interfaces, check if power is on, check if the cable is capable of transmitting signals. So most networking problems reside at the lower level. So implementing the bottom-up approach is often very effective. So a disadvantage is it requires that you check every device and interface on the network because the possible cause of the problem is found. So it is also difficult to determine which device to start examining first. Yeah, so it might take a while. So you have to know the particular host that has a problem, then you now start from that particular host. So with start with the end user application. All right, this is another way. All right, you can do from top to bottom or from what bottom to what top. So when we start from the end user application, and we'll move down through the OSI layer. So the end user application of an end system are tested before it was tackling the more specific networking pieces. So use this approach for similar problems or when you think the problem is with the piece of software. So the challenge is to determine which application to start examining first. So the disadvantage is that it requires checking every network application until the possible cause of the problem is what found. Another method is what select a layer and test in both directions. So either it starts at the transport layer or the network layer or the data link layer. So when a layer is verified to be functioning properly, it can be assumed that layer below it are functioning. So working up the OSI model. So work up the OSI layers. So if an OSI layer is not functioning properly, the administrator can work down the what OSI layer model. So for example, if the user cannot access the web server, but they can ping the server, then the problem is above layer 3. So if pinging the server is unsuccessful, then the problem is likely at a lower layer. So that's just a simple method. And then another thing to keep in mind is what follow the path. All right, follow the path, and also you can also use what substitution. So first they cover the traffic pathway, right? All the way from the source towards destination. So the scope of troubleshooting is reduced to just the links and devices that are in the forwarding path. So the objective is to eliminate the links and devices that are irrelevant to the troubleshooting task at hand. So this approach usually what complements one of the other approach. So another way is what substitution. So it's called swap. You can also call it what swap the components, because you physically swap the what problematic device with a known working one. So if the problem is fixed, then the problem is what with the removed device. If the problem remains, then the cause may be elsewhere. So can it can be an ideal method for what quick problem resolution. So such as with a critical single point of what failure. So for example, a border route goes down, it may be more beneficial to simply replace the device and restore the service, alright, rather than to troubleshoot the issue. So if the problem lies within multiple devices, it may not be possible to correctly isolate the worst problem. So we can also use comparison or educated what guesses. So this one you compare configurations, compare software versions, hardware, or other device properties. That's under comparison. But for educated problems, so you also it's also called shoot from the hip troubleshooting approach. So it's a less structured troubleshooting method that uses an educated guess based on what the symptoms of the problem. So just like a medical doctor, it asks you how are you feeling? Are you having headache? How does your eyes see? They check your eyes. Okay. That's the same way on the network now. You begin to check, okay, if you cannot send, it means that probably this is having issue. If you can ping, you cannot ping. If you can do this, if you can send message to this person and the person cannot see the message. So you just begin to look at all those things from there. Guidelines from for selecting a troubleshooting method. So guidelines for selecting a troubleshooting method. So take time to select the most effective network troubleshooting method. So remember we talked about different methods, okay? Top to bottom, bottom to top, right? Middle, all right, the substitution, the educational approach. All right. So software problems are often solved using a top-down approach. Hardware-based problems are solved using what bottom to top approach. So new problems may also be solved by what an experienced technician using what divide and conquer method. Otherwise, the bottom-up approach may be used. So there are software-oriented problems, right? Um, you can of course also see hardware, right? So hardware can be done what bottom up approach. So new problems can be done either what the bottom up or what divide. Then the experience before can be done using what the divide and conquer method. Let's look at physical layer problems. So a large portion of networking problems are related to physical components or problems with your physical layer. So physical problems are connected mainly with the hardware aspect of computers, alright, and networking devices. So, and the cables that are what that interconnect them. So physical problems do not include the logical software. All right. So you don't need to get to the application layer. All right. You just stick to what layer one, which is what the physical layer. So some of the more common layer one problems include what device receiving power, whether the power is turned off or unplugged. So loose network cable, incorrect cable type, faulty network cable, and faulty wireless access point. So ensure that there are no errors showing on the LEDs that display the connectivity status. So if on site, visually inspect what all networking cabling what and reconnect cables to ensure a proper connection. So if using wireless, verify that what the device is operational and settings are what configured correctly. So there are some layer one problems that could be what the sense of sight. So cables are not connected, cables connected to the wrong port, LEDs showing error and the rest. Then sense of touch, feel for overheated component as well as to detect the mechanical problems with devices such as cooling fans. Device create a small vibration in the component that can be detected using what touch. So sense or smell and taste. So check if something is overheating or burnt. Alright, taste is directly related to the sense of smell because both use the what same receptors such as tasting and just get the point. You don't mean you taste with your tongue. So also listen, alright, hear. You could hear sound, alright, such as electrical issue. When there's a spark, you would know. Alright, when there's an unfriendly sound, okay, you're hearing a vibration that is not usual. Alright. So wireless router LEDs. So you examine the LEDs, okay? So that indicates the current state of activity. If a piece of equipment is not disconnected, it won't be showing light. Alright. So the LED have different signs, alright, that they work with. Be sure to use correct types of cables, alright. Check UTP cables, which is either straight through or what crossover. So improper cable termination is one of the main problems encountered in network. So terminate using what the T568A or T568B standard, which is either what copper straight through or crossover. So also crimp connectors on the cable jacket to provide strain relief. Alright, check maximum cable run length. Alright, so there's a maximum amount of length before signal is being dropped. Let's look at troubleshooting commands. Alright, so most of these utilities are provided by the operating system on the command line interface. So you use ipconfig, ping, netstart, traceroute, nslookup, to verify connection, to verify communication. Alright, so you can say ipconfig. Ipconfig gives you the overall the brief or a brief word wireless information. The ipconfig slash all gives you all network information. So you can also use ipconfig command slash release to is used to what let go of the current DHCP binding. Then ipconfig space slash renew used to what obtain a new DHCP binding. All right, there are packet tracer activities to this. All right, the ping command is used to test for communication. So it most use network utility. So test whether or not network devices are reachable. Echo request Echo request message used to send was the packet. Echo reply verifies connectivity. All right. Request timeout or general failure is an indication of failure. So ping to the name like www.cisco.com verifies not only connectivity but domain name server as well. All right. So these are different ping results. So if neither a ping to an IP address nor a ping to the of name is success, then network connectivity along the path to the destination is most likely the problem. All right, so try to ping the default gateway. If the ping to the default gateway is successful, the problem is not local. If the ping to the default gateway fails, the problem resides on the local network. So ping may fail due to what? The firewall on the sending or receiving device or a router along the path that is what blocking the ping. So device and conquer with ping. So use a device divide and conquer technique to what isolate the problem to either the wired or the wireless network. So ping from a wired or wireless client to the default gateway. So this verifies if the client is what connecting as expected. So ping from wireless net client to a wired client, all right, and verify if what the router is what reachable. So you can see on this diagram here, a ping was done with a wired, can be done with a wired device. So if it is reachable, you come and check what wirelessly if it was reachable. We also did this in one of the labs. Then use the trace sat command. So the ping command does not indicate where the connection drops if it fails. So that's where the trace route comes in. So the trace route, all right, it's actually trace route on Microsoft and Linux, but or traceat, all right. Um, you can use it to what provide connectivity information about the path a packet takes to reach the what destination and about every router hops along the way. So if before your let me say you want to request for a website, okay, before it gets to your website, all right, that's your particular those packets actually jump from router to one router to another, from one region to another, okay, until it gets to the particular web server that is storing you the information of the website that you need. So when the packet is moved from one router to another, it's called hop. All right. So indicates the tracer command indicates how long a packet takes to get from what the source to each hop and back. So which is what the round trip time. Also, it's used to identify where a packet may have been lost or delayed due to what bottlenecks or what slowdown. So notice that in the output that the second hop failed, right? Which is this that says what request timeout. So this is most likely due to a firewall configuration on that device which does not permit what responding packets from the traceroute command. So however, the device does forward the packet towards the next hop. Then the net start. So the net start command is used to verify active TCP connections and list what the protocol in use. So the local address and port numbers, the foreign address and what port numbers, and the state of what the connection. So you can see this on the image here. So unexplained TCP connections can pose a major security threat because they can indicate that something or someone is connecting to the local host. So unnecessary TCP connections can consume valuable system resources. Thus, they slow down what the host. The NS lookup. So the NS lookup command. So when a network device is being configured, one or more DNS server. Yeah, I'm listening. When a user application requests to connect to a remote device by name, the requesting domain name server client queries the name server to resolve the name to a what numeric address. All right. So the NS lookup allows the user to manually query the name server to resolve a given host name. So can it can also be used to troubleshoot name resolution issues and to verify the current status of the name server. So when issued, the default domain name server configured for your host is what's displayed. So the name of a host or domain can be entered as a what NS lookup prompt. So when you enter the NS lookup, right? So you can see here when you enter www.cisco.com, you can see the server, right? You can see the address, the IP address, all right, and you can see the what name, and this is the alias that you are using, which is what www.cisco.com. But in the real sense, that's actually what origin dash www.cisco.com. So there's a lab associated with this. Let's look at troubleshooting wireless issues. So let's look at the causes first of all of these wireless issues. So the 802.111 AC standard, which is for the 5 gigahertz band, is not compatible with what the 802.11B or G or N standard, which is what 2.4 gigahertz band. So within the 2.4 gigahertz band, each standard uses what different technology. All right, that's why on your Wi-Fi router you can set up what 2.4 gigahertz SSID and what 5.0 gigahertz SSID. So unless specifically configured, equipment that conforms to one standard may not function with equipment that conforms to another standard. So for example, now in the figure, the 2.4 gigahertz network is configured to support legacy devices. All right. Each wireless conversation must occur on a separate non-overlapping channel that sometimes can be what configured. So some legacy devices, some laptops now, you see that they cannot view um, any Wi-Fi that is on the 802.11 AC standard. So if your Wi-Fi is 5.0 gigahertz, that system will not go to sit. Or if you go and buy a Wi-Fi dongle that does not support that supports only 2.40 gigahertz, when a broadcast an SSID that is on that is using the what 802.11 standard is broadcasting, all right, that Wi-Fi card or Wi-Fi dongle would not be able to what detect that network. So each wireless conversation must occur on a separate non-overlapping channel that sometimes can be what configured. So the strength of an RF signal, right, which is radio frequency, decreases with what distance. So low signal strength cause what devices to not connect or drop signals. So use the network interface card client utility to display what the signal strength and connectivity what or connection quality. So radio frequency signals are susceptible to interfaces from outside sources, including what other devices functioning on the same frequency. Do a site survey to detect for this. So access points share the available bandwidth between devices. As more devices associate with the access point, the bandwidth for each individual devices will decrease using what? Causing network performance problems. So which means the network will become what? Slower. So the more people that are connected to your hotspot, the slower your network will be moving. So you now understand when who are connected to you, and your network becomes very, very slow. Authentication and association error. So the SSID is a case sensitive. It's case sensitive. So alphanumeric strings that what can be up to what 32 characters. So the SSID must match on both the access point and what client. So if the SSID is not broadcast, it must be manually entered into the client. So when you want to manually enter the SSID, it means that you must type the correct SSID. If not, you're not going to be able to connect to the network. So if another access point is present that has broadcasted the word SSID, the client may automatically what associate to it. So on most access points, open authentication is configured by what default, so allowing all devices to what connect. So if a more secure form of authentication is configured, a key is what necessary. So both the client and the access point must be configured with the same key. If the key does not match, authentication will fail and the devices will what not associate. We talked about this previously. If encryption is enabled, the same encryption key must be what configured on both the access point and what the client. So that's the key there is just referring to what password, though, just so you know, all those WPA password. Common internet connectivity issues. So we'll look at first of all the DHCP server configuration problems. So the IP configuration that have a major impact on the ability for a host to connect to the network. So when you have not configured IP addresses, even you have configured IP addresses wrongly, all right, you're not going to your device might not be visible on the network or might not be able to connect to the network. Let's assume you put the wrong IP address when you use static configuration instead of DHCP. So a wireless router can act as a DHCP server for local wired and wireless clients and provide what IP configuration. So including the what IP address, subnet mask, default gateway, and commonly the what IP address of what domain name servers. The client table information should match the what local host information, which you can see using the what ipconfig/all command. So if the client configuration information does not agree with information in the client table, the address would be released. So which means you can use the ipconfig/release and ipconfig/renew to what get new what bindings. So if host on the wired and wireless network can connect to a wireless router and with other hosts on the local network but not to the internet, the problem may be in the connection between what the router and the internet service provider. So for example now, your wireless router can be on, everybody's connected to the wireless router, but yet you cannot browse. So then you'll now be looking at what your carrier network, whether you have MTN, there's enough data on your MTN or not, or whether there's no data on your MTN at all. Because everything will be working what fine. You'll be able to ping into ping. You'll be able to send view different host devices on that particular network and they'll be visible. You'll be able to send files across from one place to another, but you'll not be able to browse the internet. And also, you should always check firewall settings. So if a client or if all clients are obtaining the correct IP configuration and can connect to the wireless router but are unable to what ping each other or cannot access a remote server or application, the problem may be with what the rules on the what router. So you have to check all settings on your router to ensure that no security restrictions could be causing the issue. So you verify that the local firewalls on the client devices are also not preventing network functionality, because you can set up firewall on your system also. Customer support. So there are ways that you can, let's say you're having internet issue, all right, with your network device. You check out for the documentation. Okay, you read documentation, all right. It will save you a lot of time, all right, when you know the different capabilities of that particular network device. All right, you can also check online for facts, which are frequently asked questions. When you're having issue, you just check, search on Google, you see answers in places like Reddit, Stack Overflow, and the rest, Quora. You get, then uh, these internet online facts, you see them most times on the device website. All right, then you can do internet searches. All right, and you can also ask colleagues, ask experts that are experienced with these network devices or with such challenges, so they can help you out. So when do you call for help? There are many ways to contact a support desk, all right, including email, live chat, and phone call. All right. So email is good for what, non-urgent problems. Phone or live chat is better for what, emergencies. So the support desk can take control of a local host through what, remote access softwares to support. So support desk technicians will run what, diagnostic programs and interact with the host and network without having to physically travel to the site having the issue. So for the support desk interaction now, the support desk will now require information on any service or support plans that are in place along the specific details of the affected equipment. So this can include the make, model, and serial number along with what, the version of firmware or the operating system that is running on the device. So they may also require the IP and MAC address of the what, malfunctioning device. So what symptoms? They'll ask you questions like what symptoms you encountered, who encountered the problem, when did the problem start, okay, what steps have you taken to identify the problem, what are the results of the steps taken. Then for the issue resolution now, when it comes to the support desk, there are different levels. There's level one, level two, level three, on even level four sometimes. Right. So if it's a first level problem, all right, if is if once you call or once you make a call or contact support desk, all right, the person that takes your call is usually a first level support desk staff. All right, if the task staff is unable to what, solve the problem, what the person does is that immediately he forwards your call to the next level. All right, or is able to what, detect what, the kind of problem or the level of problem, and send your forward your call to the particular level that will be able to what, solve your problem. So you have to record all information. What he does, he records all information regarding the direction with the support desk. All right, with date, time, all right, name and ID of technician, problem report, okay, course of action taken, resolution, escalation, all right, and then the next level. Support desk tickets and what, work orders. So the information gathering and recording process starts as soon as what, the technician answers the phone. So after customer identification, the technician accesses the relevant customer information. Typically, a database application is used to what, manage the customer information. All right, so we've come to an end of the Cisco networking essential course on Cisco NetAcad platform. All right, so there's a skill challenge there. I'm going to activate it, and you would have from today till next week, Friday, to do it. All right, so we've learned some things like the net start, the trace route, the NS lookup utility. All right, different ways of troubleshooting problems. So you sometimes you would have to check connectivity via wired and wireless means. All right, you have to do things like ping to ensure that communication is proper or feasible. All right, you would also know when to call the help desk. All right, you know how to check for the different network information using the IP config. All right, you know that IP config has about three other commands attached to it, which is ipconfig slash all, ipconfig slash release, ipconfig slash renew. All right. So also you should know how to check firewall, all right, limitations, so that because there could be a cause for communication not being visible on a network, or possible on a network. And also sometimes you might find out that everything is working fine, you can ping, but you might not be able to access the internet, and that will be as a result of what, your carrier network or your network provider. So thank you very much for staying with me. Would resume.